Hi, Algebra 2. This is Lesson 813, the third lesson in our polynomials unit. This lesson is all about finding the stretch factor of a polynomial equation given its graph. All right, so we kind of talked about some stretch factors in that last lesson, but what we've mostly been talking about is just finding the equation based off of the x-intercepts. So that would be like if we had y equals x plus 3 times, let's say, x minus 7 squared, something like that. That tells us that our graph has an x-intercept at -3 and it has an x-intercept at +7. So remember, insiders lie. And so it goes through -3, but then it bounces at +7 since it has that exponent right there. All right, and it is a third degree polynomial because there are 1, 2, 3 factors. That double factor counts as 2. And so the end behavior should be different. So that's what my graph looks like. The number in the front is missing. So it's like a 1 right there, +1. Positive orientation means that it's increasing from left to right. And that's kind of what we talked about last class. The other form would be negative orientation. So let's say that we change that to y equals a -1 in the front, but kept the factors the same. So it would have the same x-intercepts, but it would be flipped. It would have negative orientation this time. So it would go from positive to negative. All right, so it'd still go through -3 and it would still bounce at +7, but it would just be a decreasing graph instead. So it looks something like this. All right, so today we're going to talk about how do we find that number in the front if we're given the graph. So let's get started. All right, so in our first problem, we're given this equation x plus 3 times x plus 1 times x minus 2 squared. So how well can you decide if this represents the graph? So one way that we can always decide is by testing out some points from the graph. So that's where we just plug in the x and the y values and decide if we plug it into the equation, is the equation equal with those numbers? And what can you do to the equation to make it a better fit? So let's say we plug it in and it's not equal. What we could do is insert or add a leading coefficient, a stretch factor. So let's say that we plugged in some x and y value and our equation was maybe like 2 equals 1. So 2 doesn't equal 1, but if we added a number 2 in the front, 2 times 1 would equal 2. So changing the stretch factor, doubling it, tripling it, whatever number we need, can make that equation match the graph. All right, so we are given this graph based from that equation. The reason why this works is because we have x-intercepts at -3. That represents that x plus 3. An x-intercept at -1, x plus 1. And a double root at 2. So that's where the x minus 2 squared comes from in the equation. And what we need to do is find an exact equation based off of the fact that we have a point at 1/16. This means that I know I have an x value of 1 and a y value of 16. And so what we're going to do is plug that into our equation. All right, so the very first number, 16, goes in for y. We're going to leave a, since that's what we're trying to solve for. and then we're going to put a 1 in every place that there's an x. So it's going to be 1 plus 3 times 1 plus 1 times 1 minus 2 squared. And then we're going to simplify this. 1 plus 3 is 4, 1 plus 1 is 2, 1 minus 2 is negative 1, and then we square that. All right, so remember order of operations, parentheses first, exponent next, negative 1 squared is 1, and then we're going to multiply everything out. 4 times 2 is 8, 8 times 1 is 8, so this is 8a, because we still have that a, equals 16. So then a would equal 2. We can just divide an 8 on both sides to get a by itself. And so our leading coefficient is 2. So all we want to do is plug that back into our equation for a. All right, so our equation is y equals 2 times x plus 3 times x plus 1 and x minus 2 squared. All right, in this next problem, we are given a graph, and we need to find the equation of that graph. First, we're going to answer a few questions. The degree of this polynomial actually does not match the amount of roots that it has. So according to this, there are only 1, 2, 3 roots of that equation. The first root is at 0. Second one is at 2. And that third one is at 3. All right, so this one right here is a double root because it bounces. Okay, so that counts twice. So this is actually a degree of 4. Remember, your degree of 4 has the same in behaviors, going up and up or down and down. Okay, so then our equation is going to have 3 different factors, but one of them is going to be a square. So our equation is y equals some number in the front, let's call it a, times x minus 0, which is the same as x, x minus 2, and x minus 3. Just remember, same numbers, opposite sign. Since the 2 is the double root, I'm going to put an exponent of 2 right there. And our second step is to solve for a. We know that this point is on the graph, 2.5, negative 2.2. So we're going to plug that in. All right, so we're going to plug in a 2.5 for the x's. So it's going to be a times 2.5, 2.5 minus 2 squared, and 2.5 minus 3. All right, and then y is that negative 0.2. All right, so after that we need to simplify our parentheses and then square that middle parenthesis. So after I do that, I would get 2.5 times 0.25 after the square and negative 0.5. Still got the a in the front and the negative 0.2 that equals. Multiply all that out and you would get negative 0.3125a equals negative 0.2. Remember that decimal number is still a number, so we just divide on both sides to get a by itself. So when you plug that into your equation or your calculator, you will get that a equals 0.64. All right, so then in our equation, we can just put a 0.64 in the beginning. If you're working with pencil, you could just erase that and put 0.64 right there and circle that as your final equation. So y equals 0.64, x minus 2 squared, x minus 3. That is the equation that should match that graph right there. All right, and then based on that equation, we can now figure out what the lowest point of that roller coaster is. So the lowest point looks like it's about right here, and that is when x equals 0.5. And it looks like it's almost down to the -2, so maybe it's -1.7, -1.8, something like that. So what we're going to do is we're going to plug in the x that we think it's at, and then we'll be able to find the y value. So rewrite everything except for x is going to be 0.5. You plug that into your calculator, and you can pause the video and do that now. What you would get after you plug everything in is -1.8. All right. And from the beginning, it said that it was in hundreds, so all you have to do is multiply that times 100 to figure out the feet. So it's not -1.5 feet underground, it's actually 180 feet underground. All right, this is our last equation that we're going to look at. So write an equation for the function with a graph that bounces off the x-axis at -1 and crosses at 4. All right, so that equation, first we're going to make the equation based off of the x-axis, or the roots. All right, so based on the roots, we know that's going to be y equals some type of number in the front. Since we have a root at -1, we have a factor of x plus 1, remember, just different sign. And since it bounces right there, it's going to be an exponent of 2. And we have a root at 4, so my other factor is going to be x minus 4. Okay, same number, opposite sign. All right, and that's good because that's a degree of 3, and this graph shows us that we have 2 different end behaviors, which goes with odd functions, and it is going towards the positive, so our number in front should be positive once we find that, and that's our second step. We're going to use a point that is not the root, so the only point that we have is -2, -18 to solve for or find a, the leading coefficient. So we know this means that x equals -2 and y equals -18. So we can plug those numbers into our function up here. All right, so we're going to have -18 equals number in the front, a, times -2 plus 1 squared times -2 minus 4. And so from there, -2 plus 1 is -1. Square that is +1. -2 minus 4 is -6. Times a equals -18. 1 times -6 is -6. A equals -18. Divide -6 on both sides to get a by itself, and we should get 3. Okay, and then we just need to plug that in here. So our equation is y equals 3 times x plus 1 squared and x minus 4. So we can put that in Desmos and double check that it looks like that graph. All right, so this next problem throws us for a little bit of a loop. The only difference that Armando made in his equation is a factor of 4, or an exponent of 4, sorry. And if the exponent is even, that does represent a bounce. So it does fit the given criteria. So that x plus 1 to the 4th power represents a bounce at x equals -1. If we plug in the point that we were given, -2, -18, we're going to test that in his equation and see if it works. So -18 equals 3 times -2 plus 1 to the 4th power times -2 minus 4. -2 plus 1 is again -1. -1 to the 4th power, if you multiply that out, would give us a +1 again. -2 minus 4 is -6, and when we multiply 3 times 1 times -6, we would get -18. So that does work. That equation still works with what we were given. Now, what if we threw a wrench in here and we said that we knew another point on the graph was at 1, -36? So we will test that out in both equations. So remember, our equation is y equals 3 times x plus 1 to the 2nd power instead of the 4th. And his is that 4th power right there. And so we're going to plug -36 in for both y's. And then we're going to plug in 1 for all the x's. So it's 1 plus 1 squared, 1 minus 4. This one is 1 plus 1 to the 4th power times 1 minus 4. All right, so over here, 1 plus 1 is 2. 2 squared is 4. One minus 4 is -3. When we multiply all this out, it would give us -36. So our equation does work for that point. Over here, have 1 plus 1 is 2. 2 to the 4th power is 16. And 1 minus 4 is -3. This would actually be -144 when we multiply 3 times 16 times -3, which does not equal -36. So that equation wouldn't work if that was a point on the graph. So to summarize everything, there are 3 criteria that we need to create an exact equation. The first is knowing where the x-intercepts are. Or the roots. Remember, x-intercepts and roots are the same things. So that will tell us the factors. Secondly, we need to know where are there any bounces. So if it does, then that would be an exponent of 2. For that specific factor. And finally, the first 2 we can do for any equation if it just asks us for a standard equation based on the x-intercepts. This third part is if it's asking you for an exact equation, and gives you another point that is not just an x-intercept. So the third criteria is that we need another point that is not the x-intercept. At least one other point. So that we can find A. Remember, A is our leading coefficient.